Hello friends, welcome back. Let us continue with the module of electrician trade. I am Rajiv. On behalf of Nimi, I will be guiding you through this exercise of verifying the terminals and accessories of three-phase transformers HT and LT side. As an electrician, it is essential for you to be able to read and interpret the details written on a transformer plate and identify its accessories. In this exercise, we will explain all of these. On completion of this exercise, you will be able to read and interpret the nameplate details of a three-phase transformer, verify the terminals of HT and LT winding, identify the accessories of a three-phase transformer. Ensure safety by wearing proper attire, goggles, gloves, and boots. The necessary tools or instruments required for this experiment are as follows: DE spanner set 5 mm to 20 mm, insulated cutting plier 200 mm, screwdriver 200 mm, voltmeter 0 to 500 volts, multimeter. Equipment or machines required are 3-phase transformer 415 240 volts 3 kVA, 3-phase auto transformer input 415, output 0 to 500 volts 3 kVA. Other materials required are test lamp 40 watts, 230 volts, 2 numbers, connecting leads as required. A three-phase system is universally employed for the generation, transmission and distribution of electric power. So we need three-phase transformers to step up or step down the voltages. A three-phase transformer works on a three-phase supply, and both primary and secondary windings have 3 sets of windings. The primary and secondary winding of all the 3 phases can be mounted on a single core of a three-phase transformer. Generally, the low voltage operating windings are called LT side, and the high voltage operating windings are called HT side of a three-phase transformer. Usually, the low voltage windings are placed adjacent to the core, and the high voltage windings are placed over the low voltage windings. Now, let us verify the terminals of a three-phase transformer. First of all, note down nameplate details in table. Transformer's kVA rating, voltage and current ratings of LT and HT side, frequency and cooling type. In a three-phase transformer, we would have 6 terminals. 3 terminals for the LT side and 3 terminals for the HT side. First of all, we have to distinguish the winding group. So, let us conduct a continuity test between the winding terminals. Conduct the continuity test using a multimeter to find out the 2 groups of terminals. Let us assume terminals as 1, 2, 3, 4, 5 and 6. Place probe 1 in terminal 1 and place the other probe 2 in terminal 2, 3, 4, 5 and 6 one by one. Record the condition in the table. Next, place the first probe 1 in terminal 2 and probe 2 at 3, 4, 5 and 6. Record the conditions. Similarly, check the continuity between all terminals of the transformer. Now, we can see that there are 2 sets of 3 terminals having continuity between them. Mark them as group 1 primary windings and group 2 secondary windings. Next, we have to identify which one is LT side and which one is HT. Make a connection as shown in the circuit diagram. Apply 3-phase AC to any one side group of winding, say group 1, using a 3-phase auto transformer. Vary the auto transformer supply 30 volts to the group 1 winding. Measure the voltage between any 2 terminals of the other group of windings. If the measured voltage is higher than the applied voltage, then the group 1 side windings are LT side and the group 2 side windings are HT side. If the measured voltage is less than applied voltage, then the group 1 side windings are HT side and group 2 side windings are LT side. Identify and mark HT and LT side terminals. Next, let us identify and note the accessories of a 100 kVA 3-phase transformer. Transformer tank, HV and LV bushing, buckholes relay, conservator tank, oil level indicator, breather, explosion vent with oil gauge, cooling pipes, earthing terminals. Transformer tanks are used to hold and protect the core and windings of the transformer from outside environment. It provides support to all the other transformer accessories. The tank is filled with transformer oil. For connecting incoming and outgoing cables, terminals are used in transformers. They are mounted on the bushings and connected to winding ends. Bushings are insulators that form a barrier between the terminals and the tank. They are a safe passage for the conductors connecting terminals to the windings. They are made from porcelain or epoxy resins. Buckholes relay is one of the most important safety device of oil immersed transformers rated over 500 kVA. It is an oil and gas actuated relay that is used to sense faults occurring in parts immersed in the oil, such as interturn faults, short circuit faults, etc. It is in between the main tank and the conservator tank. In case of minor faults, the gas formation is slow and will accumulate in the upper part of the buckholes container, which causes a fall of the oil level in it and activates the upper float switch to operate alarm circuit. In the case of large faults, a huge amount of gases are produced by the decomposition of oil, and this results in the oil level falls still further and activates the lower float switch to operate trip circuit, which could totally disconnect the transformer from the main supply. The oil conservator tank is a small cylindrical tank mounted on top of the transformers and connected to the main tank by a small pipe. Due to the change in transformer load, the volume of the transformer oil also varies. The conservator tank provides enough space for the oil to expand and contract with the change in the volume of the oil with respect to the change in oil temperature. An oil level indicator is fitted with the conservator tank to supervise the level of oil in the tank of a power transformer, and it gives an alert signal at low oil levels. The breather is a cylindrical container fitted to the conservator tank through a pipe and acts as a filter for air entering into the transformer. The breather is filled with silica gel, which absorbs moisture from the air passing through it, so that only dry air can enter the tank. Silica gel is blue in color when dry and turns pink when it gets moisturized. The explosion vent is fitted on top side of the transformer as a pressure release device. The end side of the explosion pipe is tightly closed using a thin glass or laminated sheet. The thin sheet explodes to release excessive pressure built up in the transformer in order to avoid explosion of the entire transformer. Heat generated inside the transformer should be radiated to the atmosphere to keep the oil temperature down. This high temperature oil circulates through the cooling tube and dissipates heat to the atmosphere by surface contact with natural airflow and hence cooling the transformer oil. The transformer body earthing terminal is connected to the main earthing bar by an insulated copper earthing conductor. Earthing for power transformer is extremely important for the safety of personnel and normal functioning of the system. This concludes the exercise to verify the terminals and accessories of three-phase transformer HT and LT side. I hope in this exercise we learned to read and interpret the nameplate details of a three-phase transformer, verify the terminals of HT and LT winding, identify the accessories of a three-phase transformer. Thank you for watching. See you all in the next exercise.